All right, so our test we've learned so far, nth term test for divergence. Okay? That only tells us a series diverges or it's inconclusive. That tells us a series diverges if the terms are not becoming zero. Okay? Because if they're not becoming zero, then I'm still adding stuff that matters. Eventually, we want those terms to be becoming zero, so we're not really adding something that matters. If the terms are becoming zero, that doesn't mean it's still going to converge necessarily. So the nth term test only tells us divergence. Then in our comparison test, we can squeeze down and say that because a bigger function converges, then the smaller one will have to converge as well, but we don't know to what. All we know is less than the other one. Okay? So in example 4, the bigger series converge to E, the smaller series converges to something smaller than E, but we don't know what. Okay? Geometric, we can know exactly what it converges to by doing A over 1 minus R. Okay? The ratio test also does not tell us what a series converges to. It also only tells us if it converges, but it can also tell us if it diverges, but then unfortunately there's also an inconclusive case. So the ratio test says, what we're going to do is take the ratio of terms n plus 1, which is series notation for next term, divided by a sub n, which is series notation for now. Okay, so we're going to do the next divided by the now, way down the line, because we're taking the limit as n goes to infinity. Okay, so we're going to do the next divided by the now from way down the line of the series. If that limit is smaller than 1, then it converges. Okay, that's kind of another, a little bit fancier way of that nth term test of saying these terms have to be getting smaller. I think there's a little bit more criteria to how they're getting smaller. If that limit is bigger than 1, it diverges because the next term is bigger than the now term, and that's a problem. Okay. If the limit equals 1, it didn't work out for us. Okay. The ratio test is my favorite test because it is useful a lot of the time. Okay. It is particularly useful when you have factorials and when you have powers, which are things that we see a lot in series. So when we have factorials or when we have powers, the ratio test is a good one to go to. So let's look at an example of how it works out. The book proves it. We don't need to prove it. That's fine. We'll just believe it works. Example 5 says, find the radius of convergence of this series. Okay, find the radius of convergence for the series. So find what x values this thing works for. Okay. I have powers in this. When I have exponents in there of n, I like to go to the ratio test. Also, if I have factorials, I like to go to the ratio test when possible. So the ratio test says that we're going to take the limit as n goes to infinity of the a sub n plus 1 term divided by the a sub n term. So what that means is a sub n plus 1 means take the series and change all the n's to n plus 1s. So n plus 1 x to the n plus 1 over 10 to the n plus 1. And we're going to divide that by the a sub n term, which is just the series with n's, or the series as is. It's pretty messy here. Fraction divided by a fraction, what do I do about that?
Bring the bottom stuff to the bottom stuff to the top, and the bottom stuff to the bottom.
Multiply by the reciprocal using appropriate math language. So I get limit as n goes to infinity. And then I want to see if there's stuff that I can cancel out here, because when we multiply, we can cancel stuff from that multiplication if it matches. So 10 to the n and 10 to the n plus 1. If I had like 10 to the second over 10 to the third,
Subtract it.
I could cancel that, right?
Yeah.
Or if I had like 10 to the fifth over 10 to the sixth, I can cancel that, right? And it just leaves a 10 on the bottom. Okay, where the bigger exponent was, that's where the 10 gets left over. Same type of thing with these x to the n's. With our x to the n's, I can cancel, and it's going to leave 1 left over where the bigger one was. So then at this point, I'm left with n plus 1 over n times x.
Over 10.
Oh, and the 10.
10. I think I know from
If n is going to infinity, I get infinity over infinity, but if I did a L'Hopital's rule on that, what would I get?
1 over 10.
1 over 10.
1 over 10.
And that's a number.
So it's
What? Oh,
So I get
conversion.
1/10 x. I don't really need my limit anymore because we did it. So the limit of this is 1/10 of x. Ooh, one thing I didn't talk about at the beginning. Here we go. Back to the beginning. Is it possible that the terms of this could be negative?
yeah.
Yeah, x could be negative. We don't know what x is. X could be negative. N is odd sometimes. So we need to throw some absolute values around anything that has an x here.
You always do that for the ratio test?
If we could have negative terms.
Just around the x's?
Just around the x. Because as long as the x
Oh,
is
yeah.
positive, then everything else will be fine.
Because even if it's like an odd number,
Right.
It can't make it negative.
Right.
No.
So our ratio test says that the series converges when the limit is less than 1. So if this limit that we just got is less than 1, then we have convergence. Is very jumpy right now. Sorry, I'm getting random marks all over. Whoop, now I'm getting a circle. Okay. There you go. Okay, it's very jumpy. Okay. So if this limit that we got is less than 1, then we have convergence. So if the absolute value of x is less than 10, then we have convergence on this. Okay? We were asked for, in this problem, the radius of convergence. If the absolute value of x is less than 10, another way of saying that is that x is between negative 10 and 10. So if we think about like our convergence on our number line, we're converging from negative 10 to 10. A radius, just like it is in a circle, is half of the interval of convergence. So our radius of convergence is 10. You always have a radius of convergence. Even if a series diverges, it still converges at one place,
0.
okay, at its center. And so our radius would just be 0, because half the width of a point is really no width at all. So you always have a radius of convergence. 0 if it diverges everywhere except for its center, and then otherwise we can solve through for that radius. Okay. If a question asks you for a radius or interval of convergence, the only 2 things you can do with it are geometric, because on geometric we know we have convergence when our ratio is less than 1, or between negative 1 and 1, and the ratio test. Okay? Those are the only 2 tests that will give you an interval or a radius of convergence. That comparison test just says yes converges or no.
Which 2 radius?
Okay?
The
Geometric
ratio.
and ratio test are the only 2 that can answer the question of a radius or an interval of convergence. Example 6 in the notes is an example of a special kind of a series that we call a telescoping series. Not really any notes here on this, so we'll just jump into the example. Okay, so we're asked if this series, we're actually asked to find the sum of this series. Okay, so find the sum of this series. What does this thing add up to? I'm going to start by coming up with some terms and see if it's geometric, because if it is, then we can do a sum. So if I plug in 1, I get 1/2. If I plug in 2, I get 1/6. If I plug in, I'm going to not write 1/6. I'm going to write,
Wait, 1/6 for real?
What half times 1/3?
1/66666.
okay,
What half times 1/3?
I'll write 1/6.
0.666.
If I plug in 3,
12.
I would have 1/12, and this thing is not looking geometric, right? Because I just multiplied by 3 and then I multiplied by 2. So that's not working, right? So geometric isn't going to work for us. We need a new strategy. Our new strategy on this is going to be partial fractions. So let's review partial fractions. Partial fractions, I'm going to make this equal to a over n and b over n plus 1. Then 1 will be equal to a times n plus 1 plus b times n. So 1 is equal to an plus a plus bn.
1 is equal to
A plus b has to be 0. And a is 1. So b is -1. So I'm going to rewrite this series then as 1 over n plus -1 over n plus 1. Okay? Now I'm going to try to write out some terms again. If I plug in 1, I get 1 over 1 plus -1 over 2. If I plug in 2, I get 1 over 2 plus -1 over 3. If I plug in 3, I get 1 over 3 plus -1 over 4. And I see a pattern developing.
1.
I get 1 plus 0 plus 0 plus 0. Does it converge though?
We don't know.
know. 'Cause
No.
What is the last term?
No,
It doesn't.
It's indeterminate because it's equal to 1.
no, it
Else
is
it's
divergent because it does not converge.
Yeah.
What is the very last term going to be? Even if it didn't work out in a perfect pair, I'm going to have an extra 1 over n, right? Which is an extra 1 over infinity, which is not really anything extra. So this whole thing is going to add up to 1. This is called a telescoping series because it's the idea of like a collapsible telescope, and that when we found these pairs of terms, it kind of collapsed on itself. And we just ended up with that first thing.
That's kind of a stretch, isn't it?
That's just what it's called. I didn't name it that.
Oh, I know.
I want to look at some more ratio tests because, like I said, it's my favorite, and I also find it to be incredibly useful, and they only have one example. So I want to try one where we have some factorials, so we can talk about how to cancel factorials algebraically. So, okay. So if directions say, figure out if it converges or diverges, you can use any of the appropriate tests that would work to give you that answer. Okay? If the directions say find the interval or radius of convergence, then we need to look and see if it's geometric, or we need to go to our ratio test. Okay? And those are the only things we can do if we need an interval or a radius. Otherwise, if it just says, does it converge, then we can do any of them. So the question on this one is, does it converge? So we could do anything, but I see a whole lot of factorials and an exponent. And when I see factorials and exponents, I always try my ratio test as my first
I really
option.
hope you never have to do this question.
This is question number 9 on your homework.
Write that down.
Everyone write it down.
Limit as n goes to infinity.
9.
And the ratio test says we do a sub n plus 1 over a sub n. So what we're going to do is take this thing and change all the n's to n plus 1s, which is going to make the top of that thing n plus 4. 3 factorial n plus 1 factorial 3 to the n plus 1.
Over.
Divided by, leave it alone.
Can we change the 3 factorial to 6 just to make it easier on us?
If it makes you happy.
Wait, is that
Do it on your
plus
own.
it's 3 and top?
It is, because I changed n to n plus 1. So
I know.
n plus 1 plus 3 made it n
It's
plus
just
4.
a nicer notation for me to write.
So you do that for both exponents and if it's just.
You do it for anywhere there's an n. Every n becomes an n plus 1. Alright, dividing by a fraction. I'm going to flip it over and multiply.
It's a 6.
And then we want to look for stuff that cancels within there. So 3 factorial cancels. The exponents we talked about in the other example will cancel to leave 1 left over where there was more. So I'm going to be left with a 3 on the bottom. Factorials. To cancel a factorial, we want to think about what a factorial really means. So n plus 4 factorial means that I'm going to do n plus 4 times n plus 3 times n plus 2 forever, right?
Yeah.
Where n plus 3 factorial means I'm going to do n plus 3 times n plus 2 forever. So I can cancel out the n plus 3 forever, and all I'm left with is that first one of n plus 4.
You just get rid of the exclamation point.
You just get rid of the exclamation point.
Is that going to be true every time we have factorials that cancel, that the n plus 1 will just be the original thing without the factorial?
As long as the two factorials are only different by 1. So like
Yeah.
n plus 4 and n plus 3, then yeah, it'll just cancel it all
Shouldn't
out
they
except
be,
for that
though?
first one. It's possible that they won't be.
Okay.
It's rare, but it's possible that they could differ by maybe 2 something. So then so then you would
just have,
actually
like,
just,
2.
you'd have the first 2 terms left over. Yep.
Why did you cancel that 3 to the n?
I canceled the 3 to the n with the 3 to the n plus 1. Because like 3 squared over 3 cubed would be 1/3. So it leaves the 3 on the bottom.
Oh, okay.
And then the last thing, we have one more set of factorials. I have an n factorial. I can cancel with the n plus 1, and it just leaves the n plus 1. Okay, so now what's left here? We canceled out a lot of stuff. So I still have an n plus 4 on top.
Yep.
Everything else looks crossed out. On the bottom, I have an n plus 1, and I have a 3.
Oh, yeah. Oh, from the 3 n.
From the 3 to the n plus 1.
No, that's
We're taking a limit as n goes to infinity. So if n goes to infinity, right now I get infinity over infinity, but I could think about taking a L'Hopital's rule and I get
4 over 3.
Oh,
3.
you just get 3.
a
1
third.
a third, yeah.
Because this is 3n plus 3, so the derivatives would be 1 and 3. So I get 1/3.
So the answer to the question is?
What's that mean? Does it converge? Does it diverge? We don't know.
It converges.
Converges to
This is
1.
smaller than 1, so it converges. We don't know what it converges to.
It
We have
converges.
no idea what this thing adds up to, but we know it adds up to something.
Could we figure out what the radius of convergence?
Not on this question because there's no x's.
Oh.
You only have a radius of convergence if there's an x in the problem.
I think there's certainly a little.
So with no x's in this one, it's just a converge or diverge, not a conditional on a radius.
Okay, so this is number 9. This is 1 through.
On this one, I want to find the interval of convergence,
Which one is this one?
not when you're assigned.
Ah.
It is very similar, however, to when you're assigned.
Hint, hint. Wait, what did you say? Find the interval?
You want to find the radius, I think, of convergence. Interval or radius. Either way, you do the same thing. We need a ratio test. Okay, unless it's geometric, you need a ratio test, and this is not geometric. So I'm going to do my limit as n goes to infinity of a to the n sub 1 over a to the n.
Would this one be?
You know what? This is geometric. Let's make our life easier and do this as geometric. How is this geometric? Okay, geometric means we're multiplying by the same thing over and over and over. When you multiply by something over and over and over, what's another way of doing that?
Divided by the reciprocal?
I don't know, plug it in.
Like, what's a faster way of writing 3 times 3 times 3 times 3 times
Like
3 to some number, right?
3 to the end.
So both of these have a power of n on them, so I can write it as the whole thing to the power of n.
Is that it?
And that makes it geometric. Now I'm multiplying by the same thing over and over and over. I'm multiplying by the
Fast.
stuff inside. Okay? So a geometric series will converge when what is true about the ratio.
If all of that is
Well,
less than 1,
less than one.
And the ratio is between negative 1, I guess that should be the positive, and 1. Multiply by 4.
Yep.
And take a square root. This is where we kind of fake it and just take the square root of the negative and just say it works out.
Hey, look at that. Is the x minus 1 squared over 4 what you'd have left if you did the n plus 1s anyway?
I don't know if it would work with ratio test or not.
Oh.
It might work, otherwise, and then yes, that would be what you'd have left over at the end. Otherwise, you might end up with it being inconclusive. I'm not sure.
Okay.
It's definitely
So
faster.
the ratio test doesn't always work.
Right, if the limit you get equals 1, the test is inconclusive. So this thing converges between negative 1 and 3. If it asks for the radius of convergence, what would the radius be? 2, because that's an interval length of 4, so half of that length is 2.
What if you had done it? What
So
if you had
much
said
faster.
x is less than the absolute value of 1? That wouldn't have you have had a problem when you tried to add the 1.
Yeah, you'd have to split it up to be able to add the 1. Yep, you could leave it as an absolute value through taking the square root, which is mathematically the better way of doing things than the way that I write it, but you would have to split it to be able to add the 1. All right, let's do one that actually turns out to be a ratio test, which was what I wanted to do.
Assignment example.
Okay, so this is definitely not geometric because it has factorial.
What do you think?
So if I want to know the interval or radius of convergence, which is what we're asked for in this one is a radius of convergence, we need to do a ratio test. So do our limit, n goes to infinity of the n plus 1 term over the n term. The n plus 1 term is going to take the n and replace it with a plus 1. Just the n. And then I'm going to divide by the plane thing, which is always going to end up being that we're going to multiply by the reciprocal of it. So once I kind of get into doing a lot of these, I save myself that step of writing stuff.
Yeah.
Instead of writing divide by the n term, I just multiply by the reciprocal of the n term, because that's what we're going to do every time anyway. All right, I'm going to clean up those exponents. So I get x to the 2n plus 3.
Where do we get?
I need to distribute that too, and then combine like terms.
Got it.
I thought that too.
So factorials. N plus 1 means n plus 1 times n and so forth. N factorial means n and so forth. So this cancels everything except for the n plus 1. On the exponents, what is our rule when we're dividing? What do we do with exponents? Subtract them. So if I do 2n plus 3 minus 2n plus 1, what am I left with? 2. So I have an x squared left on the top of this thing. So
X squared over n plus
this
1.
thing becomes x squared over n plus 1. And now here's a moment of clarity. I always forget to think about absolute values. So in the original question, is there any way that this thing could be negative?
Yes.
If x is negative, 2n plus 1 could be odd. So
Actually, isn't
we
2n
need
plus
to...
1 always odd?
To be safe, couldn't we always
Yes,
just?
2n plus 1 is always odd. It just couldn't
You
be.
just put
It is.
giant absolute values across the whole thing.
To be safe,
No.
It is easiest to calculate if they're just on the problem.
Absolute.
to be safe, could we always
You
just?
can always just throw an absolute value in every time.
Yeah.
Yep. I just always forget about it until I get to here, and then at this point you really can't solve it without the absolute value. So then I remember I need it. So that's really why I'm like, oh yeah, wait, I can't
So
do this. So
obviously,
clearly
the answer.
I forgot something. We're taking a limit as n goes to infinity of this thing. If n is going to infinity, I get what?
X squared over
Infinity.
infinity.
X squared over infinity,
Plus 1. 0.
which is
Where
0.
to define? I don't know.
Something divided by 0 or by infinity is going to be 0.
Yeah.
When does the ratio test say we have convergence?
When
It's
it's
between 0 and 1. Negative 1 and 1.
Oh, when
Negative
it's
It's less than 1.
Less than
When
1.
it is less than 1, so it is
Okay.
convergent.
Between negative 1 and 1 is our geometric. Ratio test says when this is less than 1, we will have convergence. So when is 0 less than 1?
All the time.
Always. So this is always convergent, which means we were asked for a radius of convergence. Half of always is actually still always. So the radius of convergence is infinity here.